Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 12 on chemical equilibrium and reaction rates. And this is the fourth section, 12.4, on catalysts. So let's talk about catalysts, which we know from before are substances that speed up reactions without being used up. So please write that down. And a catalyst is not a reactant, it's a facilitator. So it is not used up in the reaction, it's not involved in the reaction, its job is to make the reaction go faster. And how does it make it go faster? Well, catalysts will actually lower the activation energy of the reaction, and that is why the reaction will happen faster, because there doesn't have to be as much energy for the chemical reaction to occur. Looking in our book on page 398 at the energy diagram, we have energy and then the reaction process. We have our reactants here and our products here. And we can see normally we would have to go all the way up here to have the reaction occur. But if we have a catalyst, then we only have to go up here. So it's much more likely that reaction will occur. And then it happens faster then too. So my question is, what are biological catalysts called? If you said enzymes, then you are correct. So some examples of enzymes are carbonic anhydrous, bromelain, pepsin, amylase, and there are thousands more. Looking at our book, page 399, let's look at our enzymes. So we talked about carbonic anhydrase, and carbonic anhydrase is responsible for the conversion of carbon dioxide and water into the bicarbonate ion. So it picks up the carbon dioxide from your tissues and dissolves it into a bicarbonate ion, where it can be carried by the blood, and then once it hits the lungs, it's converted back into carbon dioxide and it is exhaled. And this is really good that your body is able to do this quickly with the help of this enzyme, because the buildup of CO2 in your body would be deadly. So we've talked about this in human biology. If you've taken that, that will make sense. Another enzyme is bromelain, and it is found in different fruits, and it helps those plants break down proteins. And from biology, we know that pepsin is an enzyme found in your stomach, and it helps break down proteins so that your body can use those amino acids to do stuff. And amylase is another enzyme found in your saliva, in your mouth, and it helps break down starches into simple sugars. So very important. Our enzymes are super important. There are also a lot of catalysts involved in the environment for good or for bad. A bad example are CFCs, chlorofluorocarbons. And then good, well, we can come up with a couple examples of that. And then we're going to talk about catalysts in manufacturing. Looking in our book on page 400, we see CFCs, chlorofluorocarbons, and these are used in air conditioning systems, refrigerants, aerosols, and in the manufacturing of styrofoam. And these CFCs are bad for ozone. They will destroy ozone. As we see, ozone is found in our atmosphere naturally, and then when it's hit by UV radiation, it breaks up into a single oxygen and then oxygen gas, and then those will reform to make ozone again. So this is needed because ozone helps protect us from UV radiation, and if ozone isn't there, then all of the UV radiation gets through, and then that would be bad for humans. However, when there are CFCs in the atmosphere, the chlorine combines with the ozone to form hypochlorite gas, I believe it's called, and oxygen. And then that single oxygen forms and you get a chlorine ion, and then it usually goes on and destroys some more ozone. And that is how our ozone gets depleted. So we would want to limit the amount of CFCs because those are a bad catalyst for the destruction of ozone reactions. And looking for good examples of catalysts, well, there are so many biological catalysts that we've already named, and without them we wouldn't be alive because nothing in your body would happen fast enough for you to stay alive. Also, there are a lot of catalysts used in manufacturing, and they help so that we can do reactions at not such a high temperature, because we know having to heat something up to a very high temperature uses a lot of energy, so that can help with the environment by not using as much energy by using catalysts instead of having very high temperatures, which also can be costly and dangerous to have those high temperatures. And looking at catalytic converters found on cars. And then these are examples of catalysts that help. There are chemical reactions that occur in the catalytic converters that take out some of the toxic gases that would all otherwise be shooting out into the atmosphere and polluting the atmosphere and also our lungs. So you'll want to do 1 or 2 examples of a good catalyst in your notes before moving on to the next thing. Cave chemistry is the next thing. So please write down calcium carbonate is in equilibrium, and then there are stalagmites, stalactites, and caves. And what do all of these things, how do they all relate? So looking in our book on page 402, we know that there are caves with stalagmites and stalactites. So the stalactites are on the ceiling and the stalagmites are coming up from the floor, and they are deposits of calcium carbonate. So how does that happen? So we know that there's carbon dioxide in the atmosphere, and it will react with water to form either a bicarbonate ion, which we saw before, HCO3, or carbonic acid, H2CO3. And so it will kind of filter through rock and pick up, the water will filter through rock and pick up some carbon dioxide and make carbonic acid. And then that carbonic acid it's a weak acid, so it will break down rock, which is limestone rock, particularly is calcium carbonate. And then it will have little calcium ions floating around in the water, and then also this bicarbonate ion. And so now we have picked up a lot of calcium ions from limestone that the water has filtered through. But where do we get those beautiful formations? So when the calcium ions that are aqueous, that are floating around in our water, when that water hits like an opening in the cave, a lot of the carbon dioxide is actually going to dissolve back out of the water and go into the atmosphere. And why does this happen? Well, the carbon dioxide, the partial pressure of carbon dioxide in the water wants to be in equilibrium with the partial pressure of the carbon dioxide in the air. So a lot of the carbon dioxide will go back into the gas form and be in the air, and then we have a lot of calcium ions that are left behind, and then they make these really pretty stalagmites and stalactites. And you can see some pictures here. So that's a really fun example of equilibrium going on and some acid-base reactions. And question for you is, have you ever been in a cave? One of my favorite caves around here is Cave of the Mounds, and that is over kind of by Madison. And there are some really pretty formations in Cave of the Mounds, and that's something that you pay and you have a tour guide that brings you through the cave. And with that, Chapter 12 notes are done. Good job, everybody. Bye.